this up.
I was like a little bit confused by 63. Like, what are they asking for? Are they just asking us to like quickly compare and like say like, oh, for like A, that's like unlikely compared to what they give us, blah 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 blah.
Based on what they're saying, which one of these would be the alternative hypothesis? So what's the claim being made?
Oh, so it's
So
like
start
multiple
with,
choice.
yes,
Okay, okay, got it. I was like a little
one of those
confused.
is the right answer. Yeah. I don't like multiple choice questions, but sometimes there weren't enough options for me to assign something. So, oh well.
Got it. Thank you.
While I'm thinking about it, everybody, if you tried out the practice quiz, I of course messed up the first one. The actual answer should be something around this. So I just didn't use my calculator correctly. I use memory stuff in the calculator. So what I did was I normally would put this number in the memory and they do 7.1 minus memory, 7.1 plus memory. I just forgot to put it in the memory. So whatever the number was in the memory is what I used. It was really, really dumb. And I love it. But that's what that should be the right answer. There's 6.18 roughly up to 8.03. Depending on, I mean, you might have used your Z-score chart and put a 2.33 here, and then your numbers might be a little bit off from mine, but that's completely acceptable. I just got mine from the T-score chart. Are you guys with me? That was pretty bad. That was really bad. So I gave myself a hard time about what a dumb mistake that was, but oh well, I'll get over it. Any other questions from anything, everybody? I'm still averaging about a 97 on my answer keys. It's pretty good. Somebody's telling me party time. Yeah. I mean, even Kobe Bryant missed a few shots. So the best of us can't always be right. All right. Although Obama, I don't know if he ever misses a shot. Anything else, guys? Anything? Nothing? Okay. Obviously, we still have the quiz today. So after class, the quiz will become active. It'll be due tomorrow at 6. Even with the quiz being due, voting is important. So please do that. Please. Our future depends on it. That's all. All right, so if nobody has any more questions, we're going to get into some more practice if nobody has questions. I'm a little surprised. All right. Let me see, where do I have this stuff? Here we go. I just posted on Canvas. Let me show you guys a couple of things. So if you go to Canvas, go to 160. Somebody chatting at me? No, thank God. All right, can't do that much technology at once. Go to modules. The quiz is here. There's a good old quiz. And watch out, I learned how to put, whatever the hell you call this thing. Is that an emoji? I've learned how to put a little, so I put a little cross fingers for you for the quiz. Oh, thanks, Jeff. That's going to help out a lot. Oh, well, I don't know, whatever. And then here, if you go to unit 9, I put, there's another practice for means. And like I just said a minute ago, we're going to learn how to do hypothesis tests for percentages. If I have a claim about a percentage. Last time we did this sheet, if I remember correctly, the forward focus stuff. Remember that? Blah, 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 blah. So that's on the video from last time. So today we're going to look at, actually, before I do this, yes, before I forget, let me do this one thing with you guys. Yes, okay, let me do it this way. All right. This is called doing it live. I'll do it live. So who remembers, and I know, hold on. Who remembers in the process of doing a hypothesis test, how to get a p-value? Have we discussed that much yet? I'm pretty sure we did at least once. So if I have a hypothesis test, and let's say that my rejection region is 1.645, and I get a Z star of 2.07. You guys semi with me out there? Okay, okay. The p-value is just the amount in the tail that my z-score makes. That's it. So what's the amount in the tail of this? What's that area is really what that's asking. Can you find out? Everybody's looking at me. Can you look that up? Do you have access to your z-score charts?
0.0192.
One more time? 0.0192, is that what you said?
Yes, 0.0192.
All right. Let's all check. Where is my z-score stuff? Here we go. There it is. So, okay. Technology. What's the spell for technology? Technologius workus. All right. That was such a geeky thing. I don't care. So yeah, 2.07. Oh, I got my negative one. It doesn't. Let's do it officially. Sure, I'll go to the positive one. So if you look up 2.07, you're not going to get the right answer. 2.0. Oh, this is going to be exciting. 2.07, I get 0.9808. And of course, that's the area, and I know you can't see this too good, but oh well, too bad. That's this area down there. So the area in my tail this way is going to be 1 minus that. So I do get 0.1292, which I think is what you said, Janek.
I said 0.0192.
Oh, shit. What did I just say? Wait, what was it again? It's been an interesting day. All right, here we go. 0.0192. Yes, you're right. Whatever I just said was silly. 0.0192. So let me come back up here. So that would be the p-value. All right, now listen. P-value is the probability that the sample could be found where it was, given that the mean is in the right place, right? This is the whole idea. This is the heart of a hypothesis test. If I find a sample that is so far away from this, another way to say that, if I find a sample that is really unlikely to find, if that's the real mean, right? If the actual mean age of people in a room is 28, and you randomly take 15 people and their average age is 80, holy shit, you have done something miraculous. I mean, that is insane. Do you guys get that? So, no, you don't. If I go into a room of 500 people and the average age is 28, and let's say I take a sample of 100 people and my sample's average is 80 years old, something is wrong. Is it impossible to do that? No. Is it unbelievably unlikely to do that? Yes. So maybe whoever told me the average age is 28 had it backwards. Maybe it's actually 82. That would make more sense, wouldn't it? That would make what I did less crazy. You guys understand? If the mean really is here, then my sample should be in here. So if I find one way out there, that is how likely it is to find a sample where I did if the mean is in the right place. So the smaller the p-value is, oh shit, whenever I talk slow, that's huge. The smaller the p-value is, the more evidence that is that the null is wrong. The stronger evidence that is that the null is wrong. Because the null is always the one that has an equal sign somewhere in it. It's always the one that thinks it's in here somewhere. I like it. So with that in mind, let me show you this shit. Let me show you something. All right. Where'd it go? Where'd it go? Where'd it go? Oh no. There you are. Yeah, this is all right. Yes, okay. So I'm really sorry. Obviously, it kind of makes sense that a lot of the studies being done recently involve COVID. So if I monetized my videos on YouTube, I wouldn't be getting money from this one, but I don't, so it's all good. COVID. That's all they talk about for some crazy reason. So look here. This should look very familiar. So what this is it's a treatment for coronavirus, for COVID, neutralizing antibodies, right? So using people's blood that have survived. Yes, exactly, Janek. The smaller the p-value, the more evidence the null is wrong. I like it. Okay, where am I at here? So they gave this to people and they found, now here's what's interesting. Of course, they compare it to a placebo, right? Of course, just to make sure it's not the power of the mind, which has been proven to have an effect on people's well-being. So one thing to notice is here's a confidence interval. So for patients who got the 2,800 milligram, we don't have to get into all the biology and all the pharmaceutical business and whatever, but just stay with me. For the patients who received that dose, the difference from the placebo in the decrease from the baseline of how much of the virus they had was negative 0.53. That doesn't by itself mean anything, but look at this p-value. Look at that freaking p-value. Oh my God, Becky, look at that p-value. Is that a small p-value? 2% chance. Well, how do you feel? It's up to you. You're the audience. You get to decide. Do you think that's small? You have no idea what to think, I guess. Or am I?
Yes.
It is. It's damn small because a standard p-value is 5%. We've known that forever. What used to determine unusual? Anything that was out here with 5%. 2% is pretty damn small. So by just giving me the p-value for situation, it tells me how significant that was. So using this dose is significant. What about a smaller dose? What about 700 milligrams? How did that do? What's its p-value? 0.38. How's that? Is that all right? 38% chance? Is that a small chance?
No.
Hell no. That's a little better than 1/3 chance, right? That's not a small chance. So in the problems we do, the alpha that they give us is kind of like a max range for the p-value to be significant. So if alpha is 0.05, then any p-value less than 0.05 is significant. It shows evidence that the null is wrong. How are we doing out there? So you are never going to see anything about alpha in the real world. The book gives it to us because we're not researchers. We don't understand p-value. We don't know how to interpret it yet. So they give us an alpha, kind of like a baseline. In an article, they're not going to give you any freaking alpha. They're just going to give you p-value, p-value, p-value. It's up to you if it's good enough or not. Somebody else could be like, no, I need my p-values to be 0.01. This is shit. Well, that's good for them. They can make their own decision. I don't know if this is making any sense. But that's why you'll see p-values and confidence intervals strewn all over the place in almost any statistical analysis that you see. You'll see those. And now I'm hoping you understand what they mean. Okay. Okay. All right. So let me stop sharing that so I can reset here. Oh, did I have another one to show you? No, I don't think so. No. I was looking for one, but I couldn't find a nifty one. Okay. All right. That's enough. So let's come back to the practice sheet here. Let's see, where are you, practice sheet? I got so much open here. Here we go. Okay. So if you go to Canvas right now, this is up on Canvas. Let me show you real quick. Hold on. Did I already show you this? Yes, I did. All right, so I'm not going to show you again. So let me pull this up here. Here, let's do this one together since it's been, half a week since we did one of these. So read through this problem. Oh, somebody have a question? You guys good? Read through this problem, and I'll sit here and sip on my tea. I can do one more. Bam. All right, so somebody help me out. In Mathish, what's the claim?
mu does not equal 24.81.
Yeah, because we believe that the average has changed. Is this thicker than normal? What the hell happened here? No, I guess not. All right. It's just you're really zoomed in, Jeff. All right. Yeah, not equal to what it used to be, 24.8. I like it. Let me see what happens if I do this. Where's that going to go? Somebody else tell me, where's that going to go? HO or H1? The O or the high?
HO.
Why do you think that?
Hi.
Yeah, this does not have an equal sign. It has the exact opposite of an equal sign. So it must go in for the high.
Oh.
What must the high always have? The high has the, I'm sorry, the ho always has to have an equal sign. Is that cool? That is fine. If you put it in the wrong place and then you write the opposite and you go, holy shit, I just wrote an equal sign and it's not in the null hypothesis, just change them around. I think I'm going to stick with this thickness. There we go. Let me stop for a minute. Is everybody cool with that so far? So is it a one or a two-tailed test?
Two-tail.
Yes, two-tailed. So the only time it's two-tailed if it's not equal to, right? Because what does not equal to mean? Bigger or smaller? That's why either direction works. It's not a one-directional thing. Let me see, chat. I don't know. HO always has to have some kind of equal sign. So HO always has to have a less than or equal to, greater than equal to, or equal to. The high then will have the opposites, greater than, less than, or not equal to. That's all there is to it. Does not equal to have an equal to in it? No. It's not equal to, so it does not have an equal to in it. Does that make sense? If the claim you write doesn't have an equals, then you put it into H1. Whatever you put into HO must have some kind of an equal sign. Is that all right? It's just the way we chose to set this up. We could have done this in multiple different ways. We weren't there when they were doing this. So this is the way it is. I'm kind of happy I wasn't there. It was a rough time. You're welcome. Okay. How are we doing so far? We're okay. Do we use Z or T or nothing? What do I have to look for? What two things do I have to check out? What's the most important thing?
If n is greater than 30.
Good. Or they maybe just tell me it's normal. So I have to see, is it normal? If they don't tell me it's normal, then I need, like you said, I need n greater than 30, and n is definitely greater than 30. Check. So that means I can do something. So I can cross nothing out. Now, z or t? What do I look at for that?
Sigma?
Yeah, we know the population standard deviation. Sigma is known. Therefore, I can use which one?
C-scores.
Z-scores. Because don't forget, why were T-scores invented? Because some guy got drunk on because they're invented to cover our ass from when we don't know the real standard deviation. That's why they were made up. So when do I use them? When I don't know the real standard deviation. I do know the population standard deviation. I'm not going to use T-scores. Why would I? Okay. All right, let me stop for a minute. Okay. So the rejection region, we already know it's 2 tails. We know we're going to use Z-scores, right? So it's 2 tails. 2 tails. Alpha is 0.05. Sorry, 0.005. And I want to use Z-scores. So of course I'm going to use the T-score chart, right? Because I'm crazy. I'm crazy. Is everybody with me? Take a minute, don't say anything, see if you can find the correct Z-scores for this. So let's see, 2 tails. Oh, did I do evil stuff here? Ooh, I was evil. I like it. Can you use the T-score chart? I forgot how evil past Jeff was. Where did it even go, Jeff? I don't know. Here it is. I got too much shit open up here. Can you, so I kind of gave this away. I got all excited. Be really careful. It is a 2-tail test. 2-tail test. Oh, this is so evil. I'm not going to be this evil on like something you have to do by yourself, but I was really, really evil and I kind of like it. So no, it's not the right Z-score. I can't use the T-score chart. Is there a 0.005 or is there? Let me see if I'm being silly. Is there a 0.005 option for 2 tails? No. All right, so I'm happy we're doing this together. Let me stop for a minute. Are you guys semi with me? Is anybody not okay that I suggested to get a Z-score from the T-score chart? Is everybody okay with that at this point? Because of course Z-scores live at the bottom. Can I always find a Z-score on the T-score chart? No. If the area I want is not up here, then I have to do it the old-fashioned way, the way we've done it before. And the area I want is not on here. Nah. So let me go back to the sheet. Where are you? There you are. Oh, I got a message coming. Yeah, they're just one more place. The Z-score chart goes 2 places. The T-score chart shows them to 3 places. So like we got, well, like the 1.645 is the same, right? We've used 2.575, but if you look at the T-score chart, it's actually 2.576. It's a little more precise. Are you with me? Somebody was asking me if they're the same. Yes, they're basically the same. Okay. I really want you guys to understand. If there's 0.005 total, how much is just down here? How much area is just right here? If there's 0.005 total, how much is just here?
0.0025.
0.0025. If I look that up on my negative chart, can you guys see the negative Z-score chart? You're all like, we're not going to tell them shit. Can you guys see this negative? Yes? Yes?
Yes.
Yeah.
Thank you. Thank you, guys. Now everybody comes in. All right. So if I look up 0.0025, I get it exactly here. Do you guys see that? That's the z-score. Negative 2.81 is the z-score that fits that bill. So negative 2.81 here, positive 2.81 there because of symmetry. Oh, this is awesome, Past Chef. That was evil. I like it. So if I want to say this in words, how do I reject the null? My sample has to get this far, or at least this far. So if my z star is what? Is greater than what?
Positive 2.81.
Yeah, if it's bigger than 2.81, it'll be up here. Or if it's smaller than negative 2.81, it'll be down here. So the null thinks it should show up here. If my freaking sample shows up here or here, that is evidence that the null dude is wrong. That's all that says. The null thinks it's in here. So if I get out here, I can reject the null. That's why this is the rejection region. So if this is true, if z star is that or that, then we reject the null. We support the high, the alternate. I like it. I like it a lot. Uh-oh, somebody doesn't like it. They left me. So just review. Up here we said, what are we talking about? Then we said, are we allowed to do something? And what can we use to do something? We can use z-scores. Then we said the two most important steps come next. What's far enough away is part C. So that's my benchmarks. I have to get that far away in either direction. How I knew it was two-tailed, certainly. How do I show evidence for this statement? How do I show evidence for the high? That's what always sets up the rejection rate. How do I show something is not equal to something else? Sorry. Go ahead. Anybody? No? How do I show evidence that something isn't equal to something else? So if I said, I think those two guys over there are the same age. I think their ages are
You
equal.
find the opposite.
No. Come on.
You find anything but that age? Like,
Yeah, well, I'm not finding. You just show that it's either less or greater. Less or greater. I don't know which way it goes in your perspective. That's why it's two-tail. What would make it one tail? We think it's decreased. We think it's gone up. We think it's less. We think it's more than that. That would be direction. That's one direction, not the band. Not equal to is two directional. Why? Because it's less or greater. How do I show something doesn't equal something else? It's bigger or smaller. It works both ways. That's why it's two-tailed. Does that make sense? No? You're like, there was a brief moment in time, Jeff, when this class made sense. And it was a glorious time. I'm sorry. But that's really all. If you end up putting a not equal to here, that's a two-tailed test. If it's less than or greater than, that's one tail because it has to be less than or greater than. Not equal to is either one works. That's it. That's all I'll say. So now down here, what do I know from the sample? I got to calculate my z-score. It's not a t-score. So what do I know from the sample? What was n?
264.
264. I like it. What was x bar?
25.29.
25.29. All right. Somebody else tell me what was sigma.
3.15.
3.15. And then what do I have to do with that before I do anything else? That's right, kids. I got to change it from a standard deviation for individuals to a standard deviation for groups of 264. Holy shite. 0.3. I don't know. 0.3, 1.4, 1.5. That's interesting. 351 fifths 0.2. I lost track. I'm gonna say it's somewhere around 0.2. Is that close enough? I should stop trying to do so much in my head. I'm gonna go insane.
I got 0.19.
Hey, look at that. That's pretty good. Sorry. I mean, come on. That's pretty good. All right. And now I can make them a z-score. What's the z-score formula? It never changes. It's my data, 25.29. That's what we saw. Minus the supposed mean, which is the number from the step 1, 24.81. Divided by the new standard deviation, 0.194. Well, this looks like it's, let me see, 0.5, 2.57. I don't know. Damn, that's a lot. I'm sorry. I need to just hang up my hat. That was really far off. All right. So before we find this, can you tell me, is that far enough away? Did we make it far enough away?
No.
Yeah, I can tell right up here that 2.47, that only gets up to like right there. That's my Z star. I did not make it in the rejection region. I did not find evidence that the null is wrong. So I fail. Does everybody see that right there? I already know the answer. I failed to reject the hoe. I fail to support the high. Let me draw a little picture here. So here's my 2.47. The p-value is in the area of the tail or tails. And since this is a two-tail test, let me see if you guys get this. Since this is a two-tail test, if you find the area in this tail, you have to double it to make it fair. So the p-value of a two-tail test is the area and the tail of your z-score times 2. So look up 2.47, find the area here, and then double it because it's a two-tail test. So if I look up 2.47, I see 0.9932. Is that cool? 9932. So that's all this stuff. So what's my actual area up here would be 0.0068. So then my p-value, so that's the area in the tail that the Z star we found makes. That's all that is. That's chapter 6 stuff. Then I take the p-value will just be twice that, or 0.0136, I believe. I believe. All right. So the p-value is sort of like an extra step. We actually already know the answer. We figured out the answer right here, and then we figure out the p-value. It's only an extra step in statistics class, because in the real world, we won't be given this. We have to identify this. because then other people can make up their mind if it's enough evidence. So,
If that problem was a
Oh,
one
sorry.
yes.
Savannah, are you talking to me? Who's talking
Oh, Alexi.
to me? Oh, go ahead.
If the problem was a one-tail test, would the p-value just be 0.0068? Okay.
Beautiful. Exactly. So it's only a two-tail test. You double it. Because in a two-tail test, don't I cut alpha in half? So it's sort of like mimicking that. So tell me this. This is really gross. All right, let me see. I'm going to redraw this picture over here. I just make points and then I end up with like a Frankenstein amount of makeup, like marking on something. I don't know if that made sense. So here's what this thing looked like. Two tails. It was negative 281, positive 281. Alpha is the area in the tails or tail of my critical z-scores. That's what the book calls it, the critical z-scores. The p-value is the area in the tail or tails of my z-score. Do you see how they're analogous? So I have a z-score that I have to try to beat, and then I have my z-star that I find. I have an alpha that I'm trying to beat, and then I have a p-value that I calculate, and this is a two-tail because we had to double it. Is the p-value we got smaller than the alpha we were given? 0.005, 0.0136 is definitely not smaller. That's another way to tell that we failed. We failed, which is fine. It means we did the test right. In this case.
Can you repeat that, what you said about the alpha is the,
Yeah. So look at this. The alpha is the area in those tails, correct? That's what the alpha is. Didn't we have to split it in two so I could look it up? Remember that? So there's 0025 here and there's 0025 there. So altogether there's 0.005 in those two tails, right? Okay. The p-value is the area in the tail or tails that my z-star makes. Alpha is in the area of the tail or tails of the rejection region z-score. P-value is in the tail or tails of my z-score. A beautiful little analogy there. Okay. Pretty much. Go ahead.
The only reason, like, you know how the pictures change is because we changed the sigma.
Where we, oh, here? What happened? Sorry, the only reason what now?
No, like, you know how you said it changes like from C to D, like how we find the one from the problem and then our own one.
Sure.
That happened because we changed the sigma.
All right, I think I know what you're saying maybe, but this z-score came from their alpha. Our z-score comes from the observations we made. There's no reason those should be at all connected in any way. Is that answering the question? I'm not really sure.
Yeah, thank you.
So yeah, whatever the hell this is, I've always got to change it. But these numbers are just going to come from observations, whereas this one is always going to come from whatever alpha is. I don't know. I can't circle alpha any more times. All right, there you go. And again, I don't know if you can think back to when we did our first hypothesis test problem. I'll bet you anything that you're more comfortable now than you were then. That does not mean you are comfortable. I understand. It's still a lot of, and I seem to keep putting a little extra in there. Of course I do. I didn't want to throw it all at you the first day. You would have walked out on me or, you know, shut your computer off. All right. So can somebody, what is our conclusion? Well, right here, we know we failed. We didn't find evidence to reject this guy. So we didn't find evidence to support the other guy. Which one was our claim from the beginning? HO or H1?
H1.
Yeah, H1 was the claim, right? So I'm going to use, this is the part that drives me a little crazy. I know this whole thing's insane, so many parts to it, blah, blah, blah. But how do I write my conclusion? You write it using which one is your claim? My claim was H1, so I'm going to use this language right here. Screw this guy. Cross through that guy. Gives a shit about that guy. This is my claim. We have not found sufficient evidence to support the claim that plagiarize, right? So we have, apologies to my English colleagues, but this isn't like major plagiarizing. This is just very minor. We have not found sufficient evidence. So that is what the word fail becomes. Fail becomes we have not found sufficient evidence to support the claim that what? What was the claim in English? Claim was the average time, the average age for women at the time of their first birth has changed from 24.81. Oh my God. To support the claim that the average age of women at the time of first birth has changed. There you go, buddy. There you go. Jambalaya. All right. So again, I know you can get lost in the details, but the HO is the guy who thought it was in here. And the H1 is the one that believes it would be out here. We got here. That's why we could not say the HO was wrong, because we were right where he thought it should be. So we can't say he's wrong, which means we can't say the H1 was right. That's what we just determined. Somebody's going to ask me to say it again. Let me see. The conclusion will always include whether or not we found it. Yeah, it's the conclusion. Now be careful. Don't use the word support. The conclusion has to talk about your claim. If my claim had been the null hypothesis, I would have used this language here, right? We have not found sufficient evidence to reject the claim that if our claim had been the null, that's the language we would have used. It's just which language do I use is which claim, which one is the claim. That's it. Good. Okay. And again, I don't mean to say it as if I'm just trying to say it slowly because this is weird. I understand this is weird. I also am trying to give you an idea that it's not as insane as people treat it. It's the words are there. You just have to use the right set. So if my claim is this, I use this one. If my claim is this, I use that one. That's it. So try to get as far as you can with this one. And I will give you one clue, one tiny little clue. You ain't using z-scores on this one. Okay, go for it. I'll sit here and somehow still earn money while I do nothing. Let me see. Oh, jeebus. What'd you guys get for the claim?
plus 10, 11.2.
Good. The sample stuff will never show up here, ever. So the claim is it's less time than the old one, which was 11.2. Which one is that going to go in for? H1 or HO?
The high.
H1.
H1, that's right, because it does not have an equal sign. So then what's the ho?
Greater than or equal to.
I like it. One or two tail?
One tail.
Yeah, because this is directional. So it's going to definitely be one tail. In fact, it's going to be one tail down there because it's less than. Does somebody see why we have to use t-scores?
I'm confused about that.
So why? Good, sorry.
Because we don't know the population standard deviation.
Exactly, that's it, that's all. We do have a standard deviation, don't we? Yes, Jeff, but where did it come from?
Mean time.
The sample. The sample. So is it a population standard deviation? Nope. So we don't know sigma, only S. And of course, what's even more important than that? What tells me I can do something?
If it's normal
Yeah, and why is this one normal?
and is equal to 45 greater than 30.
Good Lord, Jeff. There we go. Yeah, good old chicken, lettuce, tomato. Central limit theorem says go for it. So that's why I have to use t-scores. Don't just say, oh, we got the standard deviation, so we can use t-scores. That doesn't make any sense. Which standard deviation? And I'm not going to use the letter S. I'm not going to say it's a sample. You've got to read this and in context realize, oh, it came from the sample. That is S. I don't know sigma. All right, keep going. I'm sorry. I got the rhythm. Oh, yeah. All right, this is a nifty one. So what's your degrees of freedom?
44.
44. I like it. So I don't know if anybody was really paying attention. So I said, technically, if you don't have one that shows up on the t-score chart, you should go to the next one below it that shows up. But this is right next to 45. So if you use the one for that, I would take it. But technically, we should use the one for 40 degrees of freedom. Who's sharing their stuff with us? I don't understand what's happening. All right. Just wanted a musical interlude. I like it. So 40 and the alpha is 0.0025 and it's a one-tail test. So right there, you guys see that? One-tail test, 0.0025, and now I just have to stop at 40. So 2.021. So if you use 2.014, that's okay. You really should use 2.021. So we got a T of 2.021. I've already forgotten. It's on that side. So since it's over here, what's it going to be? If I put this, why am I wrong?
Negative.
Yes. So if T star, good Lord, Jeff, is less than negative 2.021, then we can reject the null. Dadgummit, support the high. So again, this is so technical, but if my sample shows up down there, then the guy who thought it was in here is wrong. That's exactly what that's saying. If I get a sample down here, the guy who thought it was here is wrong. That's the null. And the guy who thought it was not in there is right. That's the high. So step C sets up what far enough away is. So of course the next step is how far away did my sample get? So somebody help me out. What was X bar?
10.4.
And what was S?
2.34.
So don't forget this. This is where people freak out. They're like, why do I have to divide by square root of n? It's already a sample. That's not. Oh, I see. Oh, so again, anytime there is something I don't know, I must penalize myself. That's what statistics is all about. It's so technically, if your degrees of freedom is 44, you should use the next one down to penalize yourself, to make the t-score bigger, to make the test harder to pass. You don't just go for the closest one.
I got it. Thank you.
Sure. So now I got to do 2.34. That's the one that works for individuals, divided by the square root of 45. So whatever that is.
49.
Who is it?
0.349.
349. I like it. And I don't know if you guys remember, the T and Z score formula is the same. My data minus the middle, what we're assuming it to be, which is 11.2. Right? The hypothesis test is always let's assume that's right. Divided by the new standard deviation. So it really just tells me how far my sample is from what the mean is supposedly is. Let's see, 8 over 3.5. I don't know what the hell it is. 2.4. Who knows? 8 over 3.5. 16 over 7. 2.29.
Yes.
Is it?
Yeah.
Yeah.
2.29.
All right, that's nice. I like it. I shouldn't sound so surprised. I need to be more, of course it is. So what can we say right there? And it's negative, right?
Yes.
It's not that far. So did we make it far enough away?
Yes.
Yes, visually you can see we made it down there. You can look at this. Is your T star is negative 2.29 less than 2.021 negative? Check. Become a 9. Oh my gosh, Jeff. All right. Become a point. Okay. Let's see if you guys can take this. I will never ask you to find a p-value for a t-score because the t-score chart is not detailed enough. Can you find it with technology? Of course. You can do a lot of shit with technology, but then it's not really you doing it. So I don't care. All right. So I just won't ask you that question if it's a t-score test, right? If it's a t-score thing. What does that mean? The fact that we got in there, what can I say? What's my little tiny phrase? Did we make it? Did we find evidence?
Yes.
We have, yeah, so we did these, right? Reject the null, support the high. Now it's unfortunate we had 2 of these in a row, but oh well. Yo, back up. Which one was your claim? The ho or the high? The high was my claim, so I'm going to use that language. If the ho would have been my claim, I would have used the reject language. So what have we done with our claim? We have found, holy macaroni, Jeff. More cheese, less macaroni. We have found enough, sufficient evidence to support the claim that, I don't remember, that the new drug brings relief in less time than the old one. Oh my gosh. Bam. And just visually, this right here, that's my sample. It made it so far away from the mean that is the old drug that it is evidence that the new drug is less than that. Is it proof? No. Is it strong evidence? Yes. So then I can make a commercial saying clinically, it's been clinically proven to treat headaches in less time than the old drug. Have you ever heard of something like that in any commercial ever? Of course you have. And when they say clinically proven, that includes statistical analysis, which is this. It's crazy. Yep.
Can you explain whether we put the claim as the null or the high?
So you mean from way up here?
Yes.
So the claim doesn't have an equal sign in it. No. So therefore it goes in for the high. The thing that's always true about the statement you put next to this guy is it's got to have some kind of equal sign. That's it. That's it. And the reason we do that is we want the rejection region to always be set up by the high. So it can't have an equal sign in it because I can't show evidence that something equals something, but I can show evidence that something is different from something else using a sample. Okay. Oh, here comes a chat. Can you see E? Yes. You can see it. Reading it, that's a whole other thing. That's on you. We'll see if you can read it. All right, so, oh, there's a chat. Oh, you're fine. Don't worry. Yeah, that's all. Just 100 problems. Somebody's telling me they just have to do 100 problems and then they'll get it. So I'm sorry I didn't assign enough homework. All right. So, oh, I'm sure this is a, yeah, there you go. Okay. Anybody still need to see that? I want to do the next little thing up on the board. We might do one example like it, and then we'll call it a day. All right. I'm going to stop sharing and see if anybody yells at me. Okay. So, what if I have, I know, hold on, a claim about a percentage. Let me move you guys over here. Come with me. Where'd you guys go? All right. Let me straighten my room out. There we go. So what if I had a claim like we feel it is less than 40%, right? So that claim would be, oops, gather. That's the whole point, Jeff. The claim would be P is less than 0.4, right? So if you're talking about a percentage, use P. If you're talking about a mean, use mu. So pay attention to what you're doing. So again, which one would that go in for? That would go in no equal. So it would go in for the high. Can you tell if it's a one or a two-tailed test?
One tail.
Yeah, see, that doesn't change. Most of what we're doing doesn't change just because we're talking about percentages. So what will change? What will change is the second step will change and the fourth step will change. Why those two? Well, the second step is, can we use z-scores? Oh my God, Jeff, can you write? What has happened? Did you sleep on your hand? Can we use there we go, buddy. Can we use z-scores? And what is it that I check when I've got N's and P's and Q's?
P and NQ?
Yeah, they both have to be at least what?
5.
Yes. Well, get out of there. So you got to check NP and NQ and make sure they're at least 5. So of course, this isn't a whole problem, but if I gave you the sample size was 700, then you would do 700 times 0.4, that's P, and 700 times 0.6 because that's Q, right? And you get 280 and you get 420, 420, and they're at least 5. So I mean, the second step, the first step changes a little tiny bit. You got to use the letter P. I'm not even going to count that as a change. The second step definitely changes because now we're talking about percentages. So the N greater than 30 shit don't mean anything. The third step stays exactly the same. They have to tell me what alpha is, and I know how many tails it is. I can find the rejection region. The third step stays exactly the same. The one that changes the absolute most is the fourth step. All right, I'm going to take this away. We're going to do an example problem in a minute. This isn't a real problem. So just to remind you guys, the fourth step for means is where I do this thing. And I have sigma equals sigma sure. Right, that's what we've been doing. Now, that's the fourth step. We figure out z star, we have to figure out the new standard deviation, get the z-scores. Everybody with me? Now, of course, that is not gonna work for percentages because I don't know what the shit that is, right? I don't have means. I don't know what that shit is. All right, so for percentages, we have to go back and we have to steal something. Right? Get ready, kids. This is like a really boring national treasure. Like, we're not going to go anywhere, but we're going to go back to confidence intervals. Recall. Remember this confidence interval there? Right? This piece is the new standard deviation. Are you guys with me? Nothing amazing there, right? That's the new standard deviation, right? Here's the one for percentages. Can you point out to me what seems to be the standard deviation, the new standard deviation in that equation?
P hat times Q hat.
Yeah, well, no, darn it. So X bar plus or minus Z times new standard deviation. P hat plus or minus Z times new standard deviation, this whole thing. What does that mean, Jeff? My God, Jeff, for once, just talk English to me. All right, give me a minute. All right. Here's what that means. Here's what that means. When I do a z-score for a mean, I divide by that, don't I? Don't I? Right there, I divide by the new standard deviation. So when I do a z-score for percentages, I'm going to divide by this. That's the new standard deviation. So for percentages, the z-star formula is going to be my percentage. Oh shit, remember good old p hat? It's like x bars. My percentage from the sample minus the percentage in the claim divided by the new standard deviation. Now watch this. There's a little bit of a difference. What changed? Something's a little different. It migrated over and something happened.
They lost their hats.
There's no hats.
Yeah, their hats are like, here's their hats just laying on the ground. It's because I only have to use the P hat and Q hat when I don't know what P and Q are. But the whole point of a hypothesis test is I'm assuming that I do know what P is, and thus I know what Q is. Now, none of this means shit until we try a problem out. Let's try a problem out and then call it a day. How's that sound? Does that sound all right? It sounds okay to me, and that's all that matters. Here we go. That's right, kids. It's not a democracy. Maybe America's going to follow. Stop, Jeff. Be hopeful. All right. Let me see. Where is everything? There you are. So there's another sheet up on Canvas. It's called Hypothesis Practice. I can't remember what the hell it's called. Hypothesis Test Practice for percentages. Where did you guys go? There you are. Let me share this real quick. Here we go. Shlabam. All right, so let's try this out. This not controversial at all problem about police and how we feel about them. All right. So Chicago policeman claims that at most 55% of residents there have an unfavorable view of their police. Then we take a random sample of residents and ask them, what the hell you think about police? Can somebody figure out, just think about this for a minute, don't say anything yet, but how you would write the claim in Mathish? It's a little bit tricky. It's got a phrase that people don't get. What does that most mean?
Less than or equal to.
Yeah. At most means up to, right? So less than or equal to 0.55. So where's that going to go? The ho or the high?
The ho.
All right. What do you call me, Janae? I can't believe this. The indignities I have to suffer. It's incredible. All right. So what's the high going to be?
Is greater than 0.55?
Yeah, just always the opposite. So is this going to be a 1 or 2 tail test?
One.
Yeah, 1 tail. Greater than. That's a direction, right? So it's going to be a 1 tail test up there. Right? This feels the same. And I know hypothesis tests themselves are still a little new to us, but not that new. This feels the same so far. Is this normal enough to use z-score? So the nice thing with I don't know if you guys remember this, but with NPQ problems, actually, I might never have said this, but you might have noticed this. Do you see how there's 2 formulas for X bar for confidence intervals, right? One of them's got a Z, one of them's got a T. How many formulas are there for P hat? 1. It only ever uses a z-score. So you never use a t-score for an NPQ problem. But you still have to know if it's normal enough. So, of course, what do I check here?
Check NP and NQ.
Yeah, NP and NQ. What's N here? Let's see. Be careful.
$996.
Yeah, 996 times 0.55. We're going to assume that P is 0.55. And 996 times what's Q? It's got to be the rest. So 0.45. And whatever the hell that is. I don't know. So I get 547.8 for that, which is obviously at least 5. Check. You get rid of this stuff. Damn it. Go away. Okay, Jeff, it's fine. It's fine. It's fine. Check. And then this one will be 448.2, which is at least 5. Check. And that means I can use z-scores because it's normal enough. Let me stop for a minute. Whenever you have percentages, n greater than 30 doesn't mean shit. You got to check NP and NQ. N greater than 30 is for means problems. So part B being yes, that means I can do something. I can use z-scores. Now this one is not so evil. It's a one-tail test of 0.0005. So is that on the chart? Is that on the t-score chart?
Yes.
Yes. It's the first column, right? So if you go all the way to the bottom, because I don't want a t-score, I want a z-score, I get 2.576. So if my sample z-score is further up than 2.576 standard deviations, it is so far away that we can reject the guy who thinks it's in here, and we can support the guy who thinks it's higher than that. That only makes sense. That only makes sense. If I get a sample that is so far above what this guy thinks the mean is, it's more likely that that isn't the mean. The mean's higher. Why did you? Oh, don't forget, guys. What lives at the bottom of a t-score chart? Oh, oh, sorry. I was going to start singing SpongeBob SquareTees. So at the bottom of the t-score chart lives z-scores, right? These are z-scores here. That so much kicks ass. So now I've got a one tail 0.005 hypothesis test. So I go all the way to the bottom and I get 2.576. So if you go all the way to the bottom, you get a z-score. If you stop, you get a t-score. Is that cool out there? Somewhere out there. No? Is that right?
Sure.
So how do you know when to use it? You're allowed. I want to use this all the damn time for confidence intervals, for hypothesis tests. The only time I cannot use this is if I have an alpha that's not on here, like we had just a minute ago. Right? If my alpha is not on here, then I'm screwed. There you go. You're welcome. I like it. This is why we ask questions. Oh shit, where am I? I'm here. There we go. So now I was very nice here. I kind of broke this all out for you. So N was 996. X was 594. So P hat would be 594 out of 996. Don't forget, you round this to 3 places at least. So I get 0.596. Is that what you guys get?
Yes.
Notice how I don't give a shit about Q hat. Poor little Q hat. The only place that it hatted one appears is right there. So it's going to be my data, 0.596, minus the supposed middle, which comes from the claim, 0.55, divided by the square root of 0.55 times 0.45 divided by N. So you'll only ever see the hatted dude in one place. Right there. This is exciting to try to put this in your calculator. Let's see if we all get the right answer. So if you're gonna put this all in your calculator at once, which I highly recommend, put the top in parentheses. Calculator does not have eyeballs. Thank God. That would be really, really creepy. I think, I don't know. Maybe it'd be neat. I don't know. All right, let's see who can put that in the old calculator correctly.
We got 2.92.
Kick ass. Is everybody else all right? Let me know if you can't get 2.92. Please let me know. Everybody's okay? All right. So I already know the answer, right? Did we succeed or fail? Did the test find evidence or not? Visually, did I make it far enough away?
Yes.
I sure did. I made it in there. There's my 292. Can somebody find the p-value for me? There's 2.92. The p-value is just the area and the tail. It's a one-tail test. I don't have to double it. I just have to find the area. So I get 9982 here, which means the p-value is 0.0018. You guys all right out there? Or what's a better way to say that? Did that make anyone feel worse than they felt? I don't know. All right. So I already knew the answer, 2.92. 0.0018 is damn tiny. Yeah, so it's equivalent to me asking you, okay, that Z star you just found, can you find the area and the tail that it makes? That's all it is. It's a chapter 6 question. So if you look up 292, don't you get 9982 down there? Which means how much is up here? 0.0018. That's all that is. The p-value is just looking up your Z star and getting the area and its tail. That's all it is. Is that all right? Okay. So then our conclusion, so we rejected the null, right? We made it into the rejection region. We can reject the null, we can support the high, but which one was our claim? Which one was the claim? HO or H1?
Oh.
Man, everybody's calling me a hoe. All right.
HO?
The claim was the hoe, that's right. So that's the language I want to use. We have found sufficient evidence to reject the claim that plagiarized. Where'd it go? It claims that at most 55% of Chicago residents have an unfavorable view. Oh my gosh. That at most 55% of, how do you say it? Is anybody from Chicago? Is it Chicagoan? It's not Chicagonite. I know it isn't. Chicagoan? Sure, we're gonna go with 58% of Chicagoans have an unfavorable view. Of the police there. Bam. So very familiar feel. It just has this different formula for Z star, which should make sense. It's kind of like having a different formula for confidence interval for a percentage. Same idea. Any questions, guys? I think that's it for me. I think that's enough. You guys agree? Is that all right?
Mr. Waller,
Yes.
can you just one more time show us how you would know if you reject a hoe and support the high? Like what values do you look at?
Right here. Did you, so there, the rejection region, I keep trying to shade it in.
Okay.
If I make it in there, the reason we call it that is because if I make it in there, if I'm greater than this in this case, which is why I make you put it in words also. If I'm greater than this, then I can do these things. And these are not two separate statements. These are the same statement. If I think this guy's wrong, that means I think the other guy's right. That's the same thing. Do you see that? Because they think opposite things. Does that make sense?
Yes, got it. Thank you.
Yeah, because if I don't make it in there, then I fail to do those two things. And that's when we say we have not found. All right. So the quiz should be opening up at 3. So if you wanted to start it immediately, you could. Otherwise, you have until I think 6 tomorrow night to turn it in. But make time to vote. If you haven't voted yet, make time to vote. And you'll be in my thoughts if you're going to go somewhere to vote. Hopefully the line isn't bad and there's no poll watchers out there intimidating people. Okay. Anybody need to hang out for a bit? You guys good? Anybody have any questions? All right. Don't forget to do the quiz and I'll see you guys Wednesday. I'm gonna head out. Bye, everybody.
Bye.